of the axis 1. So we say this is basically square root 2 over 2 of A, right? So now we say A1 times A2, then cosine theta then will be equal to which is become 1/2 A squared cosine theta alpha or whatever, right? But what is the A1 dot A2? If you take the dot product, let's say A1 dot A2. What is it? This is just A over 2 square, and then O1 to 1, 101, right? So that gives you A squared 4 this 1, right? This is 0, 0, 0, and 1. So that's that is equal to 1/2 A squared cosine alpha. So that goes away. So cosine alpha is equal to 1/2. So that's your alpha. You can just take the alpha. You will get the alpha, right? So that's how you get the angle between any two vectors. So Miller indices. This is actually I'm surprised to see that a lot of you didn't get this right. So first of all, when you do something like that, you normally give it give an axis. Draw a cube first. Let's say it's a cubic thing. So let's draw a cube first. So when you draw a cube, you always want to give what is x, y, what is x, what is y, what is z, right? The normal, the conventional nomenclature, the conventional way to do this is, of course, take this as x, this is y, this is z. Right, the right-hand rule, right? You have going up this way, x, y, z. And this is 1, 1, 1, right? There's 1, 1, and 1. Now let's say, we say, remember, you have to take the reciprocal. When you do a plane, you have to take the reciprocal of that. So when I say something, a 4, 1, 1 plane, what do I really mean? What I mean is that it intercepts x at 1/4, not intercepting x at 4. Right? You have to take the reciprocal of that. So we have to intercept it at 1/4 here in x, intercept at y at 1, and intercepting z in 1. So that gives you the 4, 1, 1 plane. So 1/4, 1, 1, take the reciprocal is 4, 1, 1. So that's your plane. So this is, I guarantee that it will be on your exam too. Not 4, 1, 1 plane. So you have to know, of course, Bragg's law, which is 2D sine theta lambda, or n lambda, whatever. The n is not that important because normally we're only looking at the first order here. Unless your wavelength is really, really, really short, then you can take n equal to 2. And normally, in normal X-ray diffraction, n is only 1. So this is Bragg's law that you have to remember, but the equation is given. But you have to be able to use Bragg's law and calculate something. For example, I give an example here of a real lattice. All right, a real experiment. The experiment is you have a solid film, thin film, that undergone X-ray diffraction of a wavelength of 1.54 angstrom of X-ray. This is a typical copper K alpha X-ray, which is typically used in X-ray diffraction machine. This is the kind of X-ray you normally use. When you see an X-ray machine, normally it's this wavelength. It's a copper X-ray tube. We also know that the strongest diffraction peak now in this case, you see this pattern like this. But I know already given to you that 111 is the strongest peak. All right. So find what is the lattice constant of this film. If I tell you this is a cubic film, can you do that? So it's very simple. To apply Bragg's law, lambda equal to 2d sine theta. We also know that for a cubic crystal, 1 over d hkl squared is h squared plus k squared plus l squared over a squared. A being the lattice constant. So d1, the plane here, 111, will be just a over square root 3. It's 111. And now we apply Bragg's law here into this equation and say 1.54 is just 2 a over square root 3, which is d, sine theta. Sine theta is given to you here. It's 33 degrees divided. Normally, in X-ray diffraction, this is given in 2 theta. So you have to know whether it's theta or 2 theta. So theta will then be half of that. So 32 over 2. That gives you equal to 0.328. So A, now you can calculate A to be a certain 4.7 roughly angstrom for cubic material. So this is how you calculate from a point, from a diffraction peak, what is A, or what is the lattice parameter. Now, then you have to guess. Now here, the next question is, what about the diffraction peak here? The 66 degrees. There are 2 more, right? So what is this one? Now that you know the lattice parameter here, now you can apply the same equation again, and say then lambda, which is the d of this is just lambda over 2 sine theta, and we know sine theta is 66 divided by 2, or 33 degrees. We know that what A is, so what we don't know is h squared hkl. So you solve this here, now we say that h squared, k squared, l squared is actually, if you solve everything correctly, it's actually equal to 11. What will give you 11? hkl squared. Well, let's take a guess, right? Can it be 111? No, 111 will give you 3. So can it be 200 will give you 4, right? It's just 400. So let's keep on guessing. Like, what about 300? 300 will give you 11. So what's the next one? 300, if 300 will give you 11, 311 will give you 11. 300 will give you 9, sorry. So 311 will give you 11. So that's basically your guessing. You have to somehow guess, but it's a very limited guess. It's very easy to guess. It's only 3 parameters here, and take the square of each one. And the 222, it cannot be 222.